In today's video, we're going to be going over one of the most controversial yet easiest to understand design patterns, the Singleton design pattern. We're going to cover what it is, when you should use it, when you shouldn't use it, and we're going to go over some code that is not using the Singleton design pattern, and then we're going to refactor it to use the Singleton design pattern like it should be. Before we start refactoring any code to use the Singleton pattern, let's first talk about what it is. In essence, the Singleton pattern is just a way of creating a single object that is shared amongst a bunch of different resources throughout your application without having to recreate that object or lose any of the information inside of it. All of the state for that object, the variables, methods, all of those are shared among all of these different other objects that are using it, and there's just one source of information for this object, and there's only ever a single type of this object created. This is why it is called a singleton, because your application will only and can only have one type of this object instantiated at a time, and all places that use this object share that one single instance of the object. So as you can see from this example here, we have our singleton in the middle, which is our one single object, and all of our other objects, A, B, C, and D, are all using that one instance of that shared object that is going to have all of the state for that singleton inside of it, and they don't create their own instance of that object each time. And that's really all the singleton pattern is a way to create a single object that is shared amongst a bunch of different parts of your application. But this can lead to some problems with creating global variables, since these singletons are essentially global to your entire application. Having a single object that is global to your application and controls so much of your application can be incredibly hard to test, since you need to have that single object in order to test anything, and it can create a bunch of coupling between the different parts of your application where all of your application relies on this singleton object, so it becomes very hard to change or refactor that object since all of the rest of your application is so dependent on it. Lastly, you can run into what's called a race condition, where changing things inside of this singleton in different parts of your application at the same time can cause data to get overwritten or not read correctly because they're all trying to access the exact same information at the same exact time. Because of these downsides, some people say that you should never use the singleton design pattern in any of your applications, but I believe that there are certain niche uses for the singleton design pattern where it can become better than using a non-singleton design pattern. In those cases where you have certain sets of small information that needs to be shared throughout all of your application, using a singleton pattern in order to get all of that information into one coherent place can be easier to work with than having to create a bunch of different classes and making sure that those classes save the information properly and so on. So let's dive into an example of some code that does not use the singleton pattern, which I believe should use a singleton pattern, and then let's actually implement the singleton design pattern in that code. Here I have Visual Studio Code open on the left with all of the code for this project, and on the right I just have the console so we can view the output of our code. Before we get started any further, I do want to say if you are not familiar with the module system for exporting and importing modules in JavaScript, make sure to check out my export-import modules video, which will be linked in the cards and the description below, because we're going to be using that heavily in this example. To start with, we have this fancy logger class, which all it does is you create a new one, and it creates an empty array of logs, which are all of the things that you log inside of it. It has a function for logging out any message. It'll add that log to this log array that we created, and it'll also log it to the console so that we can see it. And then lastly, we have a method just to print out the number of logs that we have saved inside of our class so far. And then we're exporting that so we can use this fancy logger module anywhere in our application. And we have two uses where we want to use it. We have this first use JS class, which we are going to use inside of this implementation class, which we're going to implement here soon. We have a second use, which is exactly the same as the first one, but it's just a second use case. And then finally, we have our index.js file, which is what's actually being run over here inside of our browser for our console logs. And all this does is take our first and second implementation, and it's going to call both of those methods that we implement. So let's start by implementing this first use. As you can see, we've already imported our logger and created a new instance of it. So inside of here, let's log the number of logs that we have. So we could just say print log count, and we should know that this should be 0. And then we just want to log something to our logger. So let's just say we're going to log first file so that we know that we're in the first file. And then as soon as we're done that, we're going to print out the log count again. And we're just going to copy that because we're going to do the exact same thing in our second use case file here. But instead we're going to print second file instead of first file. And as you can see, our first file has already run, and you see it says 0 logs, printed out first file, and now 1 logs. So now if we save this file, we'll see that both of our functions will run, but you'll see that it runs 0 logs, first file, and then we have 1 log in the logger, and then it goes back to having 0 logs inside of our logger, and then prints out the second file and says that we have 1 log. And that's because in each of these files, we're creating a new instance of this fancy logger, so we don't have all of that shared information from the previous instance of the logger, because we're creating a new one every time that we import it and use it. This is a great use case for where we're going to want to use the singleton pattern, since we want all uses of our fancy logger class to actually have the number of logs in it that we've logged so far. So let's go back to our fancy logger here and implement this as if it was a singleton. The first thing we want to do is we don't actually want to export the class itself, because we never want to actually use the class. We just want to use a single instance of this class, since that's the entire idea of the singleton pattern. And since we only want a single instance of this class, we want to make sure that we only ever create one single instance in our constructor. So in order to do that, we can just use a static variable on our fancy logger. So we can say fancy logger.instance, which in this case is just a variable that we're creating, and we want this to always be a single instance of the fancy logger, and no other instance can overwrite this. So if this instance is null, that means that we have not actually created a fancy logger yet, so we want to create a new one. So we're going to instantiate this .logs to be an empty array, and then we're going to take that instance variable, and we're just going to set that to this, which is the new fancy logger instance we created. So now every single time that we run this constructor here, if there's no instance created yet, so if it's the very first time, we're going to initialize it and set our instance to whatever we're creating. And then the second time that we run this, it's just going to return down here. We're just going to say return fancy logger.instance. And essentially what this is saying is that we always want to return that single instance every single time from our constructor, instead of returning a bunch of different instances every time. And then down here, what we want to do is we want to create that fancy logger instance before we export it. So we can just create a variable, we'll just call it new fancy logger, and now we have an actual instance of our singleton. But to be able to make sure that nobody can actually mess with this, we're going to use a method called object.freeze, which will pretty much prevent this object from being changed in any way. We'll just pass in our logger here. So now this logger class cannot have any new methods or variables added onto it or removed from it by our code. And then lastly, we just want to export in the default that logger. So now we're actually exporting an instance of our logger instead of a class. So instead of all of our use cases here, we know that we're actually importing a instance instead of the class. So we can completely remove this line where we're creating a new version of the class, and we can do the same thing in here. Remove this line. And now if you save that, you see that we get 0 logs the first time that we use it. It prints out first file, and then it has 1 log. And when we get into that second use case in this file here, even though we're importing the logger, this import is just importing the exact same instance. So we still have that 1 log being persisted. We print out our log, and now we have 2 logs inside of our fancy logger, and that's because we're using one single instance, as I mentioned before. And that's all there is to using the singleton design pattern. If you guys did enjoy this video, make sure to check out my other design pattern videos and JavaScript videos, which are going to be linked over here, and subscribe to the channel if you enjoyed the content for more content just like this in the future. Thank you guys very much for watching, and have a good day.